Hello guys, today we are going to solve weekly contest 228 problems. So we solve problem one by one. First problem is minimum changes to make alternative binary string. So let's see the problem statement. Uh, in this problem you are given a string S consists of character 0 and 1. In one operation you can change 0 to 1 or vice versa. A string is called alternating if two adjacent characters are equal. For example, string 010 is alternating while string 0100 is not. So we have to return minimum number of operation needed to make as alternating. So basically, what is the problem? Let me explain one again. So this problem statement we are given 0 1 0 0 0. Let's say this type of string is given to us. So I have to change this into 101010 or 010101 type of string. So basically I have only two options. So what we do, we use the simple approach. We either try to find cost for this pattern or cost for this pattern. So cost for this pattern is we compare string character one by one, and if it's not equal then we have to make a change. So we add that cost in our answer. Same with this pattern. But there is a hack, like if you want to solve this in one single for loop instead of using two different for loop for first for this and second for this. So basically whatever 0 1 0 0 0, you have two pattern 1 0 1 0 1 or 0 1 0 1 0. So we have these two pattern. So for this we are going to make a change here, make a change here, make a change here, no change here, and make a change here. So total cost will be the 4. But uh, for this, if I go with this string, there is no change required, there is no change required, there is no change required, there is one change is required. And just wait. If you see for this pattern, whatever indices there is change required, there is no change required for this pattern because both pattern are alternative in the nature. So basically, and if you see there is no change required for this pattern, but this is the change required for this pattern. So basically we will find answer for one pattern. Let's say we find the answer for this pattern. If uh, or let's say start with one string. So start with zero string. Answer will be the total length minus whatever the answer is for the for that string. 4. So as you can see, there is a total length is 5. 5 minus 4 equals to 1. So whatever the minimum of, let's say, answer for one pattern and answer for second pattern is length minus answer. So whatever is the minimum, that will be our final answer. So let's code it. S equals to for length, count equals to, yeah, current. Let's start with 1. So let's start with this. Or we can do current with whatever we take. So 5 0 double not equals to current. If it is not equal, we have to increase our cost. So count plus plus, and each time we have to change the current. So we use OR operation here. So final answer will be the minimum of minus count comma count. Whatever is the minimum, that will be our answer. So let's check with test cases. 102 submit accepted. Let me check. So this explain this part. So basically, if your current is 0, you want current element 0, so next element should be 1. So to change this, I using XOR operation, because 0 XOR 1 equals to 1. Your current is 1, so next element should be 0. So if your current will be 1, then 1 XOR 1 will be the 0, so it automatically change the next character in the basis of current element. So I am using XOR part. Second problem is count number of homogeneous substring. Count number of homogeneous substring. So in this question, a string s is given, so we have to return number of homogeneous substring s. Since answer may be too large, return the modulo operation. Modulo 10 to the power 9 plus 7. The string is homogeneous if all the character of the string are the same. Okay, a substring is a contiguous sequence of character within the string. So basically, we have to return number of homogeneous substrings of s. Okay, so basically A double B triple C double A. Okay, so in this problem, what is given as in homo A double B double A. That's okay. So and homogeneous are those substring in which all the character are equal. So first of all, we divide our string in the form of contiguous equal number, because because we can't take BBC as our substring because all element are not equal. So that's why divide the string in the form of equal number. So basically, this is one length, two length, three length, or this is two length. So let's go with this. How many substring can be generated using this? So using this, there is three substring. First, second, if I start with the three, three substring are generated. If I start with this, there is two substring generated. This one, B or CC, B or CC. If I start with last one, only one substring are possible. This is this one. Total three substring can be six substring to be generated using CCC. Okay, and so we generalize this. If length is n, for the first one n string is generated. For second one n 1. For third one n minus 2. This goes on till 1. So this will be equals to n into n plus 1 by 2. So if I go with that pattern, so this is have 1 into 2 by 2, 2 into 2 by 2, 3 into 2, 2 plus 2 into 2 by, so this will be equals to 2 plus, sorry, 1 plus 2 plus, a mistake, into n plus 1. Oh, there should be 3. 2, 2 into 3 into 4, 2 into, okay, will be, this will be 2, 1 plus 1 plus 3 plus 6 plus 3. That is equal to this first test case. Answer should be 13. Okay, this is so. Let code our code accordingly. Just to put length. Let's say our current count is 0. Let's say okay, we have to use modulo, so let's take everything in long long equals 0 dot for loop. Current element is equal to previous element, then there is no violation of property, so we use the counter. Not then one valid consecutive string missed, so I have to calculate answer for that. Answer is plus plus 1 2 below mode to see. Okay, start C with 1 goes. Okay, check with this. Start into 15. Logic seems fine. So to tell you why I'm using C equals to 1 here, or why I'm using 922 statement. So basically, say I have a string like A. So in this case, never we never violate our first if condition, and so we never go to else statement. So we have to handle this for last consecutive part separately in the out of the loop. So that's why I'm using that condition in line 22, like that's statement in line 22, because if for the last consecutive set there is no else statement, so I have to calculate for that outside the for loop. So basically this is the whole idea for this problem. Minimum limits of bag in a bag, ball in a bag. So you are given an integer array nums where ith ball contain number of I balls. You are also given an maximum operation. So in one operation you can for you okay, we can do this operation maximum operation time. So in one operation I can take any bag of balls and divide into two new bags with a positive number of balls. For example, 5 ball can become 2 balls of 4 or 2,3. So penalty is the maximum number of balls in a bag. Okay, I have to minimize this penalty. So let's say for this example 9 comma 2, like there's only one bag of ball with 9 balls, and we can perform operation two times. So first time I divide 9 into 6 comma 3, and in second case, in second operation I divide that 6 also into 3 comma 3. So final will be the 3 comma 3 comma 3. So maximum is 3, so that's why answer is 3. If I go with 2482, so first I divide 8 into 4 comma 4, and in the rest of 3 operation I divide all 4 into 2 comma 2 set. So final answer become 2, because at the end maximum is 2. Okay, So basically, what I am thinking, we have to minimize the number of balls, maximum number of ball in an array. So what we can do, let's uh, let if I fix, I'm thinking of binary search here. So basically, what I'm thinking, that I if I fix the number of maximum ball in a bag, let's say it's equals to mid. So I calculate a number of operation required for each bag to achieve that. Like, does that number of balls in that bag should not be greater than max. So let's go with one example. If I have a bag, let's say I have a bag with 10 comma 20 comma 30 comma 8 comma 50 50 bags. So basically what we will do, uh, let's say we let's say, so let's say our array is 8 10 20 30 50, and let's say our current, and I have five number of two, yeah, three number of operations. Or let's say current mid is 10, current mid is 10. So, or maximum number of bag, um, number of maximum number of ball in a bag would be 10. So no operation is needed here, no operation is needed here because it is equal. But here I have to perform some operation because 20, because number of balls currently in this bag is 20. So I have to divide the balls in bag such manner such that each bag has at max 10 balls. So that can be calculated by 20 divided by mid, so yield value. So this is the total number of bags required for making uh, each ball in each bag less than mid. But we already have one bag, so we have to subtract one bag from here. So this is the required bag or required operation to make uh, every ball in every every bag with less, with less than this mid. So for 20 I have, let's say 20 divided by 10 wheel minus 1, that is equals to 1. For 30 is 3 minus 50, five. So total number of operation needed is 7, but cloud operation is 3. So we have to increase our number of balls in a bag. So let's say now I increase our number of bag is to 15. Okay. And no needed for 15 here, some operation 15 divided by, sorry, 20 divided by 15 is equals to 2, is equal to 30 also equals to 2, equals to 1. For 4 minus 1 is equals to 3 plus is equals to 5 operation, out operation. So I have to increase our part. So in this way we can solve this operation using binary, solve this problem using binary search. So let me show you how to code it. Let's say s बराबर 1, e बराबर we take, okay, so maximum number of ball in a bag can be 10 to the power 9, so maximum amount of our answer can be power 9, taking 10 to the power. Now for answer equals, well, s plus e to count. Count is 0. Number of required back is 0. L of I multiple by casting divided by 2 point. So if is greater than is less than a is achievable. So mid we reduce our search space reduced by mid minus 1 else let s बराबर finally answer that part. Some runtime. Okay, 10 is a stop. 10 5 18 17. Okay, I have to do minus 1 to 7. Go with fourth and last problem of the contest. Minimum number of connected tribe in a graph. Okay, in this problem a undirected graph is given. You are given an n number of nodes in a graph, an array of edges like ui to vi, which indicate there is an undirected between ui to vi. A connected tribe is a set of 3 nodes where there is a edge between every pair of them. The degree of connected tribe is the number of edges between one endpoint in the trio and other is not in the trio. Okay, so basically we have to find numbers of edges or number of vertices that is not part of the trio, and like adjacent of number of vertices adjacent to trio. Basically for 1 2 3 5 6 and 4 have one vertices which is part of trio. So our total answer will be the this 4 6 and 5, so 3. So we have to return minimum of all if there is multiple trio. So for this case there is no other vertices outside the trio, so for this answer is 0. For this trio answer will be 2, like 7. For this trio 5 6 answer will be the 2 because 6 is connected to 7, this is 1 degree. 5 7 connected to 7, this is 1 degree, so total 2 degree. And for this also 6 is connected to 2 1 degree, 5 is connected to 2 1 degree, so total 2 degree. So there is 3 trio with 0 in degree, 2 in degree, or 2 degree. So minimum is 0, so that's why answer is 0. N is 400, so basically we can think of at max n cube log n approach. Okay, okay, so we can go to n cube. Okay, so one of the basic idea is to let's say this is the our graph, the connected trio. Let's say I fix this one is our first part, so I will go with the every adjacent of this node. This I go every adjacent of this node to this and find entry of this node into this. So basically I use a for loop outside where I fix starting node. Let's say here is our starting. Then for there I go adjacent of that node. Let's taking auto I. For here I go to adjacent of I, and there also I use a law to go adjacent of this J. This K will go adjacent of J, and here I will find whether adjacent of, let's say, whether there is an entry of, so basically I will check for each I will go to adjacent of that I, and let's say that adjacent is J. For that adjacent I will go for every adjacent of that J also, and I will find whether adjacent of I contain that J or no. So basically in our example, this is I, J, this is K. For I go J. For J will go K. For K I will check whether I have the entry of K or not. So using this I will find all the trio, but the final answer will be the degree. If I will find any this trio, degree of J plus degree of K minus 6 because every trio contains 6 degree, which is belongs to that trio. Let's say for this node this is 2 degree, for this node this 2 degree, for this node this 2 degree, so total 6 degree. So that's why we'll calculate this, and I will find the minimum of all trio. So I guess in this way you can solve this problem. So to solve this problem, for edge, let's take a degree array first, and let's take a set of integer adjacent with size n plus 1. um, I'm taking set, so so that last finding part become log n. for for every edges, say many many 0 comma I1 of. So basically idea is to I will create a edge from mini to maxi to reduce reputation calculation, and of mini dot insert maxi. Adjacent of mini, for degree part I will increase degree of both maxi and mini. Of mini plus plus first part, like create the graph. This now for 1 plus for for of j, only if j of I dot find k not equals to each adjacent of I dot end, and it is a valid trio for us. I will calculate f answer equals to of f answer comma degree I of j plus 3 of minus 6. Then let's say initially f answer equals to maximum answer can be 10. So if there is no trio, so we never reach this function, f answer will not change. So if f answer is 26 at the end of the game or end of the loop, so there is no try, so I will update f equals to -1 and I return answer. Check whether it's working. I'm getting some compilation error. EDG edges 3,0. So accepted. So we solved all the 4 problems. I hope you liked it. If you have any doubt, you can ask in the comment section. Please like, subscribe.